Hi everyone, I hope you can hear me. Let's wait a few more seconds and we can get started. So let me open this and see whether this is live or not. I can see it's live. I hope you can hear me well. Thanks, Tim. So let's get started. So in today's session, we will learn a little bit about ChatGPT, and then we will use a new framework called LangChain. And we use this LangChain framework to talk to our own data. Especially we are using some Amazon product review. We will ask some questions, what customers think about the product and what are some of the issues, those kind of things. So I will assume everyone as a beginner, and then I will try to start everything from scratch. Cool. So before talking about code and other things, if you are very beginner to ChatGPT, let me quickly introduce you to this. So you can go to chat.openai.com, click new chat. So you can see ChatGPT 3.5, and if you are a paid member, you can access GPT-4. So let me start with GPT 3.5. So here you can ask questions like you can ask anything. Maybe explain encapsulation in oops. So here you can see the detailed answer and show some code using Python. So here they create some code and it will explain everything. So you can ask any questions. So since you can ask a lot of questions, you might be thinking, why can't we ask the task we are trying to do, which is Amazon.com, this product review. For example, let's copy this URL and you can ask, create a new one. How many reviews are there and what are some of the issues in this product? So it says, as an AI language model, it do not have real-time access to Amazon's database, and it says it has like 771 based on its knowledge. Let's check. So it has more than 13,429 ratings, and you can see 2,907 reviews. So obviously this is not perfect. So this is one of the problem with current ChatGPT. With plugins, it may fix few things, but still whatever we are trying to learn today will be very helpful because we can ask any questions with a private dataset. Cool. So this is normal ChatGPT. ChatGPT also provides API, which is some link like URL. You can use that to ask some questions using Python programming or JavaScript or any other programming languages. So to do that, you can go to platform.openai.com. You can see API keys. Maybe let me share this on our Slack. Cool. So here you can create new secret key. So you can click this one and you can type any name and it will create a new secret key, but you need to copy that secret key and save it somewhere. You cannot see that again, but you can delete previous ones and create new ones at any time. So that's one thing. Then the other important thing is always monitor the usage. Sometimes if you are doing lots of OpenAI, and there are some technologies like Auto GPT, Baby AGI. If you are doing those kind of experiments, it will call OpenAI models many times, so that will add up. So always it's good to monitor your pricings, as well as you can set some threshold. I think you can see that in billing or settings, usage limits. So here you can set some threshold. Once you hit that threshold, you will get some email notifications. So that might be helpful. Cool. And let's go to Playground. So here in Playground, you can see some mode. So we are focusing more on chat mode, and you can see GPT 3.5 Turbo. And if you have access to some other models, you will see that here. And let's ask some questions. So there are few things here. One is system and other is user. And if you run something, you will see some answer that is AI. So we will start from here. So we can create something which is called prompting. So we are going to do that. So let's say you are here, maybe translator. English to French. User. Hello world. Summit. And it converts to French. That's assistant. And you can add more things. What is 2 plus 2? I hope it converts this to French. Yeah, you can see it here. Yeah, this is Playground. You can create some context and then you can ask questions. And there are a few things like temperature, maximum length, and these things like top P, frequency penalty and presence penalty that diversify the data. So what I mean is, language models is trained on predicting the next word. So if you are always predicting the next word, like I like this movie, for example, let's say you are predicting the word movie, there is no nothing interesting there, because if you are using like temperature 0, it always there is no randomness. So you can see it here, controls randomness, lowering results in less random completions. As the temperature approaches 0, the model will become deterministic and repetitive. So if you want to add more creativity and a little bit new results every time, you can increase this temperature. So that's one important thing. Let's say you're doing some scientific journal or something like that. You no need to increase the temperature too much. But let's say you're doing some creative writing and some other things like that needs more creativity with word choice and other things. You can play with this temperature, increasing it. So that's helpful. And maximum length. So here you can ask what's the maximum length of tokens to generate. So you can read this one here. So request can up to 2048 or 4000 tokens shared between prompt and completion. The exact limit varies by model. Our token is roughly 4 characters for normal English text. So let's say this one, like what is 2 plus 2? Here we can call this as each word as a token. I think there is another thing called embeddings. Maybe I'll share that later. But for now, you can see these things here. Maybe now I'm going to introduce few more concepts and some of the issues with current ChatGPT and how we are going to fix that. So let's go to our notebook. So let's say, so far what we have seen is we played with ChatGPT. Maybe let me zoom a little bit. Cool. So one of the main issues currently is no real time. So it cannot access internet, no real time. And another issue is token size limit. So what I mean by token size limit is, let's say you're trying to do some big chunk of text. For example, let's say 10,000 word document, and you cannot put all the 10,000 word document here, and you cannot ask any questions because that crosses their limit, word limit. So we should work on some way to cleverly pass relevant chunks to the system, to the context, so that our results will be more perfect and accurate based on our data set. So that's one issue. So token size limit. And so another major problem is we cannot use the ChatGPT website like this for our private data set. So no private data set yet. So now I'm going to introduce a new framework. Maybe before introducing a new framework, let's talk about some of the high-level concepts, and then we will learn about the framework. So far what we have learned is, we learned what is prompt. So prompt is like getting some context and asking something to do to the model. So in this case, where is this playground? Here. So this is my prompt, and then hello world. This is also my prompt. So this hello world has access to this one, which is a context, and this one. So when I ask what is 2 plus 2, it also has access to hello world and this answer and this one. So this is chat history. Cool. So also we learned what's temperature. So temperature controls the creativity of the model. Then we learned maximum length, which is tokens, max tokens. So these are some of the limits. Max token is a limit. So we will address how to fix those things when dealing with our own dataset. Then let's quickly learn about, maybe I will talk about embeddings while seeing the data. So this is an interesting concept we will learn. Then let's talk about our problem. So we have a data set. So we have a data set. Somehow we should load our data set. So let's say there are like 50,000 reviews. We cannot pass 50,000 reviews to the model because of token limit. We have to split the data into many parts, many chunks. Let's do that. Split document. So here we will have many chunks. Then what we do is, we will try to convert each chunks to some long numbers. For example, let's say for this token, for this chunk, we'll have a very big number, like I think 1536 size is more than 1500. So we will represent each chunk with some high dimension numbers like 2.3, 0.4, like that. We call this as embeddings. So embeddings means it's a process of converting some text to high dimension numbers. For example, let's say you're dealing with word like mobile phones, and then maybe computer. Let's say dog, cat. If you represent mobile phone in some 1536 dimension, let's assume this is a really high dimension. but I'm converting that to a 2-dimension to visualize. So mobile phone sits here. And if you plot the same for computer, maybe computer sits here. For dog, it could be here. For cat, it could be here. Cat, dog. So we need to find a way to convert convert these chunks to high dimension numbers, and we can store that high dimension numbers in some database. So that's the next step. So here we have done the split. After split documents, we will create embeddings. Then what we do is we store this embedding somewhere. I will tell you what are different ways to store, but for simplicity, let's keep this as store embeddings. So whatever we have seen so far, this process is called ingestion process. Maybe let's color these things similar so you will understand these are belongs to the same process called ingestion process. So now so far what we have done is we have got some data set, then we load the data set, we split that data set into many parts, then we created embeddings, then we store the embedding somewhere for our future retrieval. Then the next steps are like this. So far we have a huge embedding box. Let's assume this is like the embedding store. We can also call this as vector store. For each embedding chunk, it's stored here as a number. Cool. Now what we can do is we will receive some questions from the user. For example, let's say the question is like this. So what people talk about cat? So what people talk about cat? So if this is a question, we can convert this question to some embedding. Then what we can do is we can find similarity score, like what's the similarity between this embedding versus maybe this is, let's say this is mobile phone embedding, let's say this is computer embedding, and this is cat embedding, this is dog embedding, maybe another cat here. So in this case, our question is about cat. So what happens is we will try to find the score between each document and our question. In that case, we will retrieve this document and this document. So though these two documents contain something about cat, so whatever people are going to ask about cat, maybe this document is highly relevant and helpful for the model. So this process is called lookup. Then what we do is we create a prompt. So the prompt has context plus question. So our context is to retrieved document. Cool. Then we pass this to the model, we will get some results and we display the results to the user. So in high level, so this is the approach we are going to follow. So we have a data set, we will load the data sets some way, and then we split the data set into many chunks. Then we create embeddings for that. Then we store that as an embedding vector store. Then we get the question from user. Then we will try to find the similar documents. Then we put the document as well as the user's question to the model. Then we will get some answer. Cool. Let's do that. Maybe let me open this in another browser. so that if there is any audio drop or something, I can quickly find that. Cool. Can you hear me now? I hope the audio is back. Thanks, Tim. So he says, since I started scrolling the notebook, there was no audio. Maybe let's quickly go through that one more time. Cool. So let me quickly talk about this. So I already talked about how to find the API key. You need to put your API key as a string. Then you can set OS environment as OpenAI API key as your key. And here you can get some product from Amazon. Then I have written some code to scrap all the reviews, but I'm not going to run this now because it's going to take some time. But I found a similar dataset that does exactly the same dataset. So we are going to use that one. I will share dataset and the other things to you after our session. So far what we have seen is there are different steps we have to follow. One is we need to find a way to load the dataset, split the dataset into many chunks, then find embeddings, then store the embedding somewhere. Then when we get the input from user, you have to, maybe let me mark this. So when you get some input from user, you have to combine the relevant documents as well as question, which is prompt, context and question. Then we pass this to the model, OpenAI model, you will get the results. So this is the process. We can do this by ourselves, but it's going to, it's completely achievable. We can write code to do all these things with just Python and OpenAI library. But we are going to use LangChain, which does exactly this, like all these steps are covered in LangChain, which is very helpful. And also this LangChain library is actively very much contributing. So every day they do lots of different ways to load documents. I think they have more than 30 or 40 different ways to load different types of documents like text, images, files from Slack, PDF, and many more. It's very helpful. And also they have many vector stores. Maybe we'll talk about one by one as we go. But for now, what you have to do is you have to install LangChain, pip install LangChain. I have already installed LangChain here. Then we are going to do a few things. One is we use OpenAI embeddings to create embedding for our chunk of text. Then we are going to use Chroma, which is a database, to store embeddings. So this is a wrapper around Chroma Db embeddings platform. So we'll use that. So there are different vector stores. Chroma, then Facebook has Files, then Pinecone, and many more. Chroma is a perfect choice for small data sets, but if you're dealing with large volume of data, you can use Pinecone. But for simplicity, I'm using Chroma. Then this text splitter will split our big documents to smaller chunks. Then there are some things like OpenAI, which is helpful for the model. Then it also has a large language model, OpenAI Chat, so we'll use those things. Then they also have so many document loaders. We will use data frame loader from document loaders. They have more than 30 or 40. We will see one by one. So far I have run this code. Then so here you can see different document loaders. So if you have a dataset in ChatGPT, you can load CSV loader, data frame, Discord, email, PDF, HTML, Python, many more. Cool. So I downloaded this dataset from Kaggle, Amazon Unlocked Mobile. So let's load this. So I will share the dataset as well as the code after our session. So now I loaded the data. Cool. Then this dataset has different brands. So let's focus on Apple. So I'm randomly selecting 1000 data points for quickly running everything, but if you have more time, you can use all the data. So here I'm loading this data frame using data frame loader. Then our documents is here, loader.load. So length of documents is 1000. Then we can split each document with some chunk size 1000, and if we need to have some overlap, we can have an overlap of 100 words, 100 chunks. So these things depend on the use case, but for simplicity I'm keeping like this. But the ideal way is we have 1000 data points, 1000 reviews. What we can do is we can put all the reviews in a single text. Then we can reduce the chunk size and we can play with that. But for now, I'm using exactly as it is. I'm considering each row as a chunk, each data point as a chunk. So we are using OpenAI embeddings. Our embedding is OpenAI embedding. But with this LangChain, we can also use Hugging Face embeddings and other embeddings. But for simplicity, I'm using OpenAI embeddings. Okay. So for database, which is vector store, you have to install Chroma Db. You can do pip install Chroma Db. You can uncomment this and you can run this. Then we are going to create a vector store, which is we have our text here. Then we have our embedding functions. Then we can use Chroma from documents. So this will load all our text and then create an embedding and store that in Chroma Db, which is doc search. I lost signal for 2 seconds. I hope it's back. Cool. So what we have done so far is we loaded all the dataset, and then we use Chroma Db, and then we created embeddings for each chunk of text, and we stored that in Chroma Db. Then we are going to use retrieval question answer, which is a chain. I will explain what chain and different types of chain. But for now, let's import this. Cool. So our question answer model is retrieval QA from chain type. Our large language model is OpenAI. I'm just using a default model, which is text Davinci 003, but you can also use different models like GPT 3.5 Turbo and other models. Chain type equal to stuff. So there are 4 different chain type. I will explain one by one. Maybe let's start with stuff. So there are four things. So I will talk about advantage and disadvantage of each. So let's start with stuff, then map radius, so there are 4 chain types, which is stuff, map radius, refine, Map-Rerank. They are also actively developing in this area, but in future, let's say if you are watching this video after 1 or 2 months, you might see a few more. But for now, there are only 4: stuff, map radius, refine, re-rank. So let's talk about stuff for now, and then after seeing some of the results, we will play with other things. So stuffing, so which means you pass all the data to the model at once. So pass all the data, pass all the context. So stuff can be useful when the dataset size is less. So let's say where there are very few length of the data, like very small document, you can do stuff. But if it crosses like more than 4,000 something tokens, you cannot use stuff. You will get an error message. In that case, there are different things like map reduce, refine, and Map-Rerank. They might be helpful. But for now, let's use stuff because we are dealing with a small data set. After some time, we will use different chain. I will explain all these chains and its advantage and disadvantages. Cool. 1 second. Still my audio is good? Yeah, okay. So we are using stuff. So let's run this. So now I'm asking, so what people think about moving from Android to iPhone? Let's say I have an Android mobile. I want to know whether this mobile is worth buying, like iPhone. What people talk about similar experience. So it says people who move from Android to an iPhone generally find that iPhone has a lighter feel, a larger screen size, and a faster response time to task. People also appreciate the sophisticated visuals and materials of the iPhone. Many people feel that the differences between iPhone 4, this is very old review, are more pronounced than the differences between the 4 and 4S. People who have, okay, this is very old review document. That's why you can see some of the old mobile phone reviews. So another question is, does people think owning the iPhone worth for their money? So if I run this again, you might get different results. So it says, yes, people seem to think that owning an iPhone is worth their money. So judging from the context given. So the context is all the 1,000 reviews because we have randomly selected 1,000 data points. So we use that for now. So let's ask a few more questions. So does it slow down after some use? Let's run this. So yeah, few people might have noticed if we are using this for a long time, it slows down. It depends on the 1000 data points, but if you use most of the data, you might get different results. Cool. So far I talked about stuffing. So there are some advantages in stuffing. Maybe let's talk about those and move to next one. The main advantage of stuffing is only one API call. One API call. So that's the main advantage. Disadvantage is token size limit, context length. So most of large language model, they cannot have more than 4000 tokens, something like that. So if you're having a large volume of text, you cannot use stuff method. So that's the main downside. Max token length. So this is an issue for stuff. So now let's talk about the other technique called Map-Reduce. So maybe let me talk about Map-Reduce visually. Let's say we have many chunks of data, chunk 1, chunk 2, chunk 3, and many more. So let's say this is our question. We need to find relevant documents to the model. So what we do is, if you're using Map-Reduce, we use our question for each chunk. For each chunk, we ask it to summarize or ask some particular question. So let's say there are like 10 chunks, you do 10 API call. Then finally you use the results and then do the final call and you will get the result. So the main advantage here is it can scale to larger documents. Advantage, scale well. And also we can do these calls in parallel because it's not one chunk is not independent, not dependent to the other chunk. So you can do parallel calls. So we can speed up the process. So the disadvantage here is, so we might need many API calls. Also, it loses some information during final combined call. Losses information in final combined call. Cool. That's Map-Reduce. Before talking about refine and other method, let me quickly check Slack to see if there is any questions or any audio issues. Okay. Cool. So now let's talk about refine. So in refine, what we do is, let's say we have 10 chunk. Sorry, I lost audio for a second, but I quickly found that I lost. So let me repeat refine. So in refine, what we do is, let's say we have got 10 different chunks. So what we do initially is, we have a question, then we pass the question to the first one, and you will get you will do an API call and you will get a result. Then in the next call, you pass the refined result and the next chunk, then you will do another call. So you will get another result. So this result has some idea about previous results. Then let's say to do this on this one, you have a question, you use the previous refined result, then you do a final API call. In that refined, you will get the high-level overview of all the previous chunks. So this has some advantage. The main advantage is it can pull in more relevant context and may less lossy than this one, Map-Reduce. So that's the main advantage. So main advantage is information, maybe more relevant context. So the main disadvantage here is it might need more calls and we cannot parallel, no parallelization, no parallel. Cool. So now let's talk about the final one, Map-Rerank. So Map-Rerank is very similar to Map-Reduce, but you will have a score for each chunk. So each chunk has some score. So with chunk score, you can pass only the relevant chunks to the next one. So you don't need to pass all the previous information, you pass only the relevant ones. So the disadvantage here is we cannot combine information between documents. So that's a main disadvantage. So let's say when there are many chunks, let's say only 1 or 2 chunks has some answer. In that case, Map-Rerank can be helpful. In other cases, we can play with refine and Map-Rerank. Cool. Now let's do Map-Reduce. And you can ask some questions. So Map-Reduce, we will having so many calls. So it might take a little bit longer compared to the previous ones. And it might cost a little bit if you are using GPT-4 or 3.5. So it entirely depends on the use case. You can choose the best one based on the use case. Cool. I think with this, I'm going to end our session. I hope you learned a little bit about LangChain and ChatGPT. Maybe let's summarize what are the things we have seen so far, and then I will end the session. I will share the notebook on our Slack. Yeah. So the main, you can use ChatGPT website, but the main issue there is it's not real time. There is a token size limit and you cannot use private data for now. Then we learned about, maybe let's mark this. We learned about what is prompt and what is temperature. We learned about maximum token length. We also learned what is embeddings. Then we try to do the project. So in that project, we have used Amazon Review dataset. Then we load the dataset. Then we split the dataset into many chunks. Then for each chunk, we created embeddings. Then we store the embeddings as a Chroma Db. So this embedding store is also called vector store. Then in future, when you get some question from the user, what you do is you do a lookup and find the relevant documents. Then you pass only the relevant documents to the model and you will get the results. Then we learned about different chain types like stuff, Map-Reduce, refine, Map-Rerank. Since our dataset is small, we use stuff, but you can also use Map-Reduce, refine, and Map-Rerank, and you can play with that. Cool. I hope this was helpful. Thanks everyone. See you all next week. Thank you. Bye.